trick, but pretty obvious. It might have worked in the 1800s, but step it up, guys. And then the ball's in wooden rods. Therefore, I'm on a spinning globular mass in an outer space vacuum. Yeah,
Yeah,
okay.
isn't that
Take
amazing?
your meds, please.
Yeah, how did they do all that jumping the hoops through all of that shit with just Cavendish
I
nonsense?
just can't believe it.
Unbelievable. Fucking crazy people, man.
And it's all that's the thing that really solidifies it for me is day after day. That's all they come through this room with.
Hmm. Yeah, all this time.
Every time.
I think these scientists are afraid. I mean, the reason they don't want to think, they give reasons like, oh yeah, it's well known the Earth is a globe, blah blah blah, but they just don't want to look at it because they are really afraid of finding it's completely wrong, and then all of their whole life's work and
Yeah.
their whole
I know an
careers.
astrophysicist, and I would say that that's true about him. Yeah.
Yeah, they're so
That's their
reliant.
existential fear.
Yeah, they're so reliant on what they've done, their career. It not only goes, it's from the foundation of their very identity all the way up into their 401ks that they are invested in all these global companies. Also, they don't want all of a sudden this whole house of cards to fall because of lack of participation, which is eventually, I think, is what's going to happen. These organizations, these liars like NASA, they've been caught. Like what they could tell everyone on Earth that flat earthers are just little radical group off the side. Don't pay attention to them. Yeah, a lot of people are figuring it out on their own. So
it's going to grow.
It's an avalanche. They can't stop it.
It's going to grow like a lot of other things did. I mean, it's still sort of a small movement, a small awakening or whatever. But I mean, there's not nearly as much awareness about corruption and stuff like that in general 20, 30 years ago as there is now. This will be the same thing.
Yeah.
I mean, this is a little meta, but you guys ever wonder like why flat Earth suddenly like became so prominent in the last 7 years?
I don't know. It might have been interjected into our thoughts and into the internet. It could have been put in there on purpose.
So they could get ahead of it.
Maybe.
Yeah, so do you guys ever wonder if this was even like preempted by the powers that be? So that
that's what we think. That's what I think. It was possibly preempted by them. Yes. The very ones that are censoring us right now are the ones who interjected it into the narrative in the first place.
Right, we're sort of their testing grounds to see how it will be received and so forth.
Yeah, and I think a few certain people for some reason were chosen. I'm not sure if that was organic or not. Like, how would I ever know that? But it just seems really odd that at the time. Well, there's other people in here that know more about the timeline of what was going on because I stopped looking at what was going on in the world for a long time. Just trying to solve my own problems and achieve a balance. And so there might be people that know what was happening back in the political scene and the other parts of the scene out there, like internationally, and like conflicts. And I couldn't fucking care less. I didn't even watch like anything about the news except the weather girl in the morning. That was it. And she was hot.
I gotta say though, I completely disagree with that because I just can't see any logical pathway of how the people pushing the globe would push flat Earth anywhere and have it benefit them. I can't see that.
I can see the benefit being in getting ahead of the narrative and being able to insert their own.
Hegelian dialectic.
No, well, yeah, but they can do that without inserting it, though. They can do that anyway.
I don't know that they would do that. I'm just saying that I could see that angle possibly, but I don't know that that's what happened. So
yeah, but
what I'm saying is it's not even an angle because they can just run that program of doing their best to get ahead of it as people are waking up to it anyway. So that can be a policy without inserting it.
But Orion, how would they know? How would they have their finger on the pulse of what was going on unless it was in the internet and they could get an idea?
By doing a poll with a smaller group of people instead of waking up a bunch of people to it.
A poll? I haven't seen any polls of
Yeah,
flat
it's, study groups, not a poll. I guess maybe not that, but like studies on the way that people react to things. Anyway, the point is like you can counteract it without I don't know. I'm just saying it doesn't make any sense to me.
Without instigating it, I guess. Yeah, I could see that, but I don't know. I can't divine their methods or their motives. I don't really know exactly how they operate. I mean, I could rationalize a reason as to why they would, but I don't know ultimately.
The only way you can make sense of it is if the psychotic clown is one person. He's a psychotic clown, and he's in charge. I'm telling you.
My guess is that it may have been just a few documentaries that happened to catch traction on YouTube that maybe weren't censored for a while and maybe got passed around before the censorship ramped up. And then on top of that, I think it was also the fact that long range optics have been right around that time period became more popular in regular civilian use and ownership. Long range optics that can absolutely easily falsify the radius. Some people can do this even on accident.
Like once it got beyond like 30 times like zoom, then they went up to like almost like 80 that the Nikon has. That's the highest zoom, right, in a standard camera, except the P1000, I guess, goes to further. Yeah, you could be right on that. I think it's a combination. I think people did start waking up to this. I don't know how they got their pulse, their finger on the pulse of it, though, in the beginning, though. Like, that's what it doesn't make sense to me. Like, it was put out there and then as a testing ground to see what the reaction would be and how many people catch on to it, because I don't know what they're thinking, but they're dinosaurs with their space thing, and they probably know it. They're like going to be extinct soon.
I think there's going to be a huge overhaul of like the whole materialistic narrative. Like already the simulation thing is like starting to supersede, right? The random monkey spinning monkey ball model, bang random spinning monkey ball model. We're going to go with simulation. And I mean, I still, I'm not. I'm not sure, Orion. Like, there could be. You're aware of this notion of the Hegelian dialectic, right? Like, sort of, you control both sides, then you pit them against each other, and then you see what happens. Mm-hmm. You see what the result is, and then you sort of capitalize on that. I mean, that's what they've been doing throughout history, right? Capitalism, communism. It's like revolution, so forth.
Mm-hmm. This is the first time it's probably the first time there's been this much dichotomy amongst people in a long time.
I'm not sure if that's what the Hegelian dialectic is. I think the Hegelian dialectic is problem, reaction, solution, where you create a problem, present a solution, even though you create the problem. You create a problem, you get a reaction from the public. You present a solution, even though you created the problem, they jump on the solution and you get them to do what you want. No, take away your constitutional rights.
But it's just
security.
Like
we're going to fight the terrorists and all that.
Well, the formula of the Hegelian dialectic is thesis, antithesis, synthesis, right?
Exactly.
So they have one thing, they get the opposition, which they control, and they use the two, they mash them together to get the outcome they want.
Yeah, it's the same thing. It's kind of the same control system.
But what would the opposition that they control be like? Wouldn't they have to control people claiming to be flat earthers in order for this to fit in?
Yeah,
that's what we're asking. Yeah.
So who would that be then?
FE Society and is failing miserably, I guess.
Right.
Oh well, yeah. I mean, I guess that's true. I guess, but I mean, like, I thought you were talking about like someone with like a YouTube thing or something.
No, then you got the anti-flat earthers. That's another group. No.
Well, there could be some of the YouTubers. I don't know. I don't want to name drop or anything, but some of them. I mean, let's just say I'm more impressed by the people in this room.
Some of them.
Wait. I think that's still not Hegelian dialectic though. That's just controlled opposition.
Thesis, antithesis, synthesis is literally from Hegel's treatise. take it.
But listen, controlled opposition is part of the Hegelian dialectic, like in Nazi Germany. Like it's the same thing as the people that were sent in to start the fire, and then claim it was some other group, and then already have a group in place to fight against this other group. Like it's the same thing. It's the same kind of setup.
Wait. The way that played out there was Hitler, got some of his goons to set fire to the Reichstag, and then he stated afterwards that in order to keep our security, we need to restrict some of our rights. So where's the controlled opposition there?
Because are you thinking about that this was all done like Hitler didn't do anything. He was told what to do by the people.
Yeah, I know. I'm just simply saying that the Hegelian dialectic is something important, but it just doesn't fit what we're talking about here. Was what I'm saying.
Well, I
think it does.
I think it does.
Flat versus Earth is not flat. It out. That happens.
Yeah, that they're going to want to control our side, right? They're going to want to plant their people in the opposition to steer it the way that they want to, right?
Yeah, and they're already in here.
Everything else.
You can tell which ones too. They think they're slick, but they're
That's
not.
The thing. They think they're slick. Yeah.
Yeah, they think they're slick. They think they're just sliding in under the radar, and just because they say they're a flat earther, no one knows, but it's not true.
I would almost have that suspicion about that Russian vids guy, but I think he's just a nut job. I think he's just an idiot.
Which guy? Is this the Scorpio dude or?
It goes by RV Truth or Russian vids or whatever. I don't know. It just kind of makes me not feel great about the idea of well, anyway, the point is he gives flat earthers a bad name by being a nut job that just makes claim after claim, baseless claim after outrageous, extraordinary, baseless claim, presents no evidence, hides behind a stupid picture of someone more badass than he is, and it's just terrible, I hope that guy doesn't get more popular in the future. Probably won't.
Also the Ewar guy.
I don't know. There's some strange stuff with all of that. That was. I think people get into sensationalism. Actually, they get a channel. They've had it for a long time. They get protective about it. They get territorial, and then they think they are their channel, and then people get lost in themselves. It is the ego at play. So yeah, people say a lot of stuff that's
swallowed by their ego. No longer.
Yeah, a lot of people want the attention, and they want to be someone that provokes people to extremes, possibly for sensationalism. They get a rush from it or something.
I think it's that a small group of people are smart enough to realize that the Earth is flat and understand that the Earth is flat, but then at the same time stupid enough to think that, oh, now that I figured that out, I can never be wrong about anything else. Anything I think is true is absolutely the truth, and they're like that.
There are people like that, and there are people like that here. It's true.
Other note, absolutely gorgeous luminary this evening.
Yeah, and isn't it beautiful? Wow. Yeah. Absolutely.
Imagine
incredible.
if you were on that thing, how freaking bright it would be.
Yeah, you'd be blinded, man. You would be completely blinded.
Just disregard the whole story. Requires a globe, requires a outer space vacuum. Nah.
Do you think they had moon glasses on when they were on the moon?
When they're in the desert, I don't know. It depends on how bright the studio lights were.
They have moon screen? We have to ask these questions.
Well, I don't know. I wonder what Kubrick used, because NASA probably just borrowed them or whatever.
Do you guys think that the moon is an apparent image? Do you think that it sort of fades out the closer that you get to it, the same as the stars seem to do, or what's going on?
That's a good question, man. I don't know. I've never seen the moon while in an aircraft that I can remember. I might have. I just don't remember.
Because it seems that the higher we go up, the more that stuff just sort of goes dark. I wonder if that same goes for the moon or what.
I don't know, man. It seems so close tonight. I swear, it looked like it was just right above the buildings. But I mean, I know it's behind them, quite a ways behind them, but it doesn't seem that far, man. It's like,
Well, at the very least, I'm pretty sure that doesn't apply to the sun because, you know,
Yeah.
when I climbed Mount St. Helens, at least one of those times, you know, I kind of got sunburned a little bit.
yeah, you can get sunburnt in the mountains for sure.
Well, if it's sort of a, you know, opposite equal of the sun or something like that, dual luminaries, then maybe the same would apply, but it's just absolute rampant speculation hour here, so I don't know.
It's more ethereal than the sun. Like the sun is like constant; it's sort of the same thing, and then the moon is sort
Yeah,
of
and the moon waxes and
crazy.
wanes, and yeah.
It kind of is like the masculine and feminine. I mean, I think that the ancients got that right, and then the fact that women have this time of month, so forth. It's like
It's really strange. It's a very strange object, the moon, though. It's more. I mean, the sun to me just appears like a bright light, some kind of bright torch. I mean, not a torch, but a light. Yeah, a light. And
yeah,
so does the
it's the light.
moon, but the moon, yeah, is like just like it says in the book that it's a night light. Okay, so it's a night light, but when you look at it, it looks really odd.
Yeah, it
It's like,
does.
what the fuck is it doing there? And how does it just do what it does? And I'm looking at it as like a machinist, and I go, like, that thing is perfectly fucking round.
Yeah,
Perfectly round. Just like a lens.
It's the
and that
same.
image on it that never changes.
Yeah, like a lens, a screen on a lens, a light shining through a screen, like, or a flash bulb or something. I don't fucking. That's why. Listen, when E Waron was talking about the thing, I looked as hard
The
as I could. I'm like,
projected
I
image,
can't
yeah.
fucking do it. Yeah, I can't fucking do it, man. I can't
Yeah.
get in with this. But then I started thinking about, look at the way the moon looks. And I thought of it as a reversed image, like it would make it look like the old flash bulbs looked when you went. Tsh, then you would see this pattern on the flash bulb. The moon looks like that. So I was going, well, could it be some kind of flash bulb with these lights up there? A flash bulb that is a projection of our actual Earth. And I don't know. I was
Like
looking
the
at it tonight, I'm like, fuck, I don't know, man.
it's like the craters and that are the pattern of the element. The
Yeah,
element that lights it. Yeah.
If you look at the moon though, like up close with a telescope, I mean, you can see the the line. You can see like the craters and stuff, and you can see the light move across it.
You can see it
There's
in
something
image.
definitely.
You can't necessarily determine that it's a solid rock with craters or something like that.
yeah.
Oh yeah,
There's a
you can.
definite
You
image.
can see the shadow move across the termination
Yeah,
line.
that doesn't mean it's what you're thinking it is because it's only optical. Like there's nothing you can't tell what the source of this light is.
I don't know where the source of the light is. I'm just saying you can tell that it has like actual. It's got texture to it.
It
It's
makes
got
it look like
craters.
it sure looks that way, doesn't it? But how can you verify it?
You can see stars through it during dawn and dusk.
Yeah, so I agree sort of with what he's saying to an extent where through a telescope it does kind of look like a rock, but yeah, you can see stars through it. It does seem to be translucent, so it also looks the other way too. And I'm wondering if we even see it if you go further up the same way you don't see the stars, so I don't know.
We should ask Ewan. We should do like a magic school bus field trip.
Look at UAP's video from about a week ago. Let me see. I'll see if I can find it. I'll post it. And he's looking at the moon with his P900. It looks really fucking weird, man. And past the Terminator line, you would expect to see things going laterally out to the side and the dark portion, with the lighted portion being on the right. And where the Terminator line is, you can see little things lit up in the wrong place where you wouldn't expect to see them if it were something that was fading out, where let's say you're seeing a lit side of a crater and then all of a sudden it fades out to where it's in the dark. Well, these things are like above the surface, and the way the surface looks, it looks like it dropped off completely, almost straight off where that Terminator line was, but there was still lights, like lit up section, a couple little dots here and there that were above the Terminator line. I don't know. You have to watch it. I'll find it. It's hard to describe it.
Yeah, I'd love to take a look.
It looks really fucking strange, man. This thing looks like it's egg shaped, like it's a like
The
it's
moon
a
is one of my
plate.
favorite mysteries.
It is mine too. Here we go. I found it. I'll paste it. UAP. Very freaking odd.
Beauty. Well, I'm gonna head off to bed, guys. Nice talk.
Yeah, me too. I gotta go too. Nice talking with y'all.
Yeah, catch you later.
Have a good sleep, guys.
Where
You staying up for a bit, Rookie?
Yeah, for a little bit.
Cool, cool.
What about our Bill from Coast to Coast? How'd that come out? Real quick, is Coast to Coast still going? Not all the physics. I say not.
Oh, what a day! What a lovely day!
Welcome to Science versus Scientism. I'm your host, Nathan Oakley, and joining me this evening is John, otherwise known as YouTuber Quantum Eraser. How you doing, John? Good to have you.
Hey, Nathan, thanks for having me.
Pleasure, as always. I understand you want to launch straight into ripping gravity a new one and educating people in the ways of science. So let me know when you're ready and you can launch straight into it.
I'm ready. Is my screen up?
We'll be in about 5 seconds. Yep,
okay.
You're up.
So before we get into this, I noticed personally a quite substantial uptick in the vitriol and negative waves from the ball embracers in my general direction. The ball huggers have now shifted their focus from the Wiki Road Scholarship to my mom, my alma mater, and my breeding potential. I don't know, but I think I have the cure for what ails this. And maybe it'll cheer them up and calm the waters. We'll talk about science. How about that? All
Sounds
right.
good.
The queen of science. Experiment. This is real easy. From the University of Rochester, Physics Department, the scientific method distinguishes science from other forms of explanation because of its requirement for systematic experimentation. That means if you don't have an experiment, you don't have science. From Introduction to Theory and Application of Molecular and Quantum Mechanics, the final arbiter of truth in science is experiment. From the Chair of Physics at Yale, Professor Shankar, the only way things change in physics is experiments. Everything is based on experiment. That's the only way we change our mind. From Richard Feynman, if it doesn't agree with experiment, it's wrong. And that simple statement is the key to science. I think we're getting the message here. Let's do a couple more. From Max Planck, experiment is the only means of knowledge at our disposal. Everything else is poetry, imagination. And finally, again from the Physics Department at the University of Rochester, the scientific method requires that a hypothesis be ruled out or modified if its predictions are clearly and repeatedly incompatible with experimental tests. Further, no matter how elegant a theory is, its predictions must agree with experimental results if we are to believe that it is a valid description of nature. In physics, as in every experimental science, experiment is supreme, and experimental verification of hypothetical predictions is absolutely necessary. So there should be no questions here. If you're going to make a claim and it's scientific evidence, you got to have an experiment. So what's an experiment? Well, it's a hypothesis test. The hypothesis is actualized. So a scientific hypothesis. A scientific hypothesis is your experiment statement. I know, shocking surprise. It expresses a testable proposed cause and effect relationship, the phenomena that was observed in step one. It's a classic if this, then that motif. However, not every if and then statement is a hypothesis. Let me make that clear. From the Physics Department again, from the University of Rochester, the scientific method requires that a hypothesis be ruled out or modified if its predictions are clearly and repeatedly incompatible with experimental tests. You see this predictions over here? This is a scientific prediction. It's not a Gene Dixon, Edgar Casey carnival tent prediction. This is a scientific prediction. Every scientific prediction must have one of these. From Nature, California Institute of Technology physicist Sean Carroll arguing in The Edge that hypotheses aren't simply useful tools in some potential outmoded vision of science. They are the whole point. A scientific hypothesis is based on cause and effect. reasoning. A scientific hypothesis does not merely state X and Y may be related, but explains why they are related. And that's from Lowell C., Becoming a Successful Scientist, from Cambridge. From Drexel University, the scientific method is hypothesis-driven. One makes an educated guess to explain a cause and effect relationship. From the University of North Carolina, an independent variable is the presumed cause, whereas the dependent variable is the presumed effect. The IB is the antecedent, whereas the dependent variable is the consequent. From California State, scientific hypothesis, a special kind of prediction, there's that word again, right? That forecasts how the independent variable will affect the dependent variable. From California State, formalized hypotheses contain two variables. One is the independent, the other is the dependent. Hopefully that's clear. Independent variables. In an experiment, the independent variable is the variable that is varied or manipulated by the researcher, and the dependent variable is the response that is measured. Again, an independent variable is the presumed cause, whereas the dependent variable is the presumed effect. The IB is the antecedent, whereas the DB is the consequent. From Penn State, the independent variable. It is what is varied during the experiment. It is what the investigator thinks will affect the dependent variable. From Colorado State, the independent manipulated variable is the variable changed by the scientist, what the investigator is testing. From Physics About, the two main variables in an experiment are the independent and dependent variable. An independent variable is the variable that is changed or controlled in a scientific experiment to test the effects on the dependent variable. So, they're all on the same sheet of music. They're all saying the same thing. So, a viable independent variable must satisfy two criterion. Number one, it's the presumed cause, but it's not a presumption in and of itself. For example, vitamin C or insulin. We're not presuming them. They exist. Number two, it is what is varied and manipulated in an experiment to test its effect on the dependent variable. So let's pick out the viable independent variables here, and we can just use one of these conditions, or both, or any of them. I'll just pick varied and manipulated. So insulin and vitamin C, can we vary and manipulate those? Yeah. The ball Earth. Can we vary and manipulate the ball Earth? No. Heat. Can we vary and manipulate heat? Yeah. Can we vary and manipulate the sun? No. Can we vary and manipulate light? Yeah. Can we vary and manipulate Mars? No. Can we vary and manipulate time? And that's not stopping your watch or a clock. The clock is not time. And can time be a cause? Does time cause the sun to rise? Does time cause the difference of scores between the first and third quarters? I don't think so. So, and where do we get scientific hypotheses from? Well, step one of the scientific method, observation of a natural phenomenon. So let's go through an example. So let's observe a phenomenon. Healthy type 1 diabetics suffer from diabetic ketoacidosis, apparently from the absence of adequate insulin. So the alternative hypothesis, given otherwise healthy type 1 diabetes patients, the lack of insulin will lead to diabetic ketoacidosis. The null hypothesis, given otherwise healthy type 1 diabetes patients, the lack of insulin will not lead to diabetic ketoacidosis. So the independent variable here is insulin, or the lack of. It can be manipulated. And the dependent variable, the effect or the prediction, is diabetic ketoacidosis. This is a viable scientific inquiry. Both hypotheses are viable, and so are the independent and dependent variables. Now, I want to stop here for a minute and take a look at this alternative and the null. Is there any similarities between these two guys? Right? It looks like they're mirror images, save for the fact that the alternative is will and the null is will not, correct? They are mirror images. That's what these guys need to be. The wiki parroters out there, you know, we've been hearing it. I don't know where they got this from, other than wiki, that science can't prove anything. It can only disprove, right? Well, they're clumsily attempting to parrot without any background whatsoever, which is hilarious, by the way. The goal of every single scientific inquiry is to reject or falsify this guy, the null hypothesis. Okay? How do we do that? Well, we confirm or validate the alternative hypothesis, right? These two are the antithesis of each other. So if we test the alternative hypothesis, that gives us the answer as to whether we can keep the null or it's rejected and falsified. I hope that's clear to everyone. In conclusion, the null hypothesis or the zero difference hypothesis from California State. To do a hypothesis test that's an experiment, you will actually have two hypotheses, the null hypothesis and the alternative hypothesis, which are stated in such a way that they are mutually exclusive. You can't have both hypotheses be true. The null hypothesis is the conclusion that is considered the default. That is, you will accept this hypothesis if you fail to find sufficient support for the alternative hypothesis. So we're going to accept this if we fail to find sufficient support for this guy. Hopefully that's clear. When you prove this, you ipso facto reject or falsify the null. It's just that simple. So, experiment. What's an experiment? From Penn State, there should be 3 categories of variables in every experiment: the dependent, the independent, and the controlled. The independent variable, the cause, that which is varied and manipulated. Remember, it has 2 requirements. It's varied or manipulated by the scientist to produce the effect. The dependent variable is the effect, the result, or your prediction. And the controlled variables, variables that are held constant so as not to confound the test. You don't want anything in there confounding your results. From explorable.com, experimentation. There are 3 important variables you have to remember when you're designing your experiment: the independent, the dependent, and the controlled variables, right? Pretty much lining up. Let's go to Wiki. Let's see what Wiki has to say about this. The Wiki experiment. An experiment is a procedure carried out to support, refute, or validate a hypothesis. Experiments provide insight into cause and effect by demonstrating what outcome occurs when a particular factor is manipulated. So I want everyone to take a wild guess what that factor being manipulated is. It's the independent variable, like we just went over 25 times. So in conclusion, I'm going to leave this up for a couple minutes. In conclusion, the alternative hypothesis, this is how you differentiate between these guys. The alternative hypothesis is independent variable plus your dependent variable, that's the cause and the effect, equals a prediction of cause and effect. The null hypothesis is the independent variable plus the dependent variable equals prediction of no cause and effect. The zero difference, the null, no. And the experiment is the independent variable plus the dependent variable plus what? The controlled variables equals prediction of cause and effect. Hopefully this is getting through and this is clear. So there won't be too much more confusion over this. All right, science. The intellectual and practical activity encompassing the systematic study of the structure and behavior of the physical and natural world through observation and experiment. So, what's the natural world? All of the animals, plants, and other things existing in nature and not made or caused by people. What's the physical? Well, of, relating to, or resembling material things or nature, the physical universe. So, the definition of physics from physics.org. The dictionary definition of physics is the study of matter, energy, and the interaction between them. But what that really means is that physics is about asking fundamental questions and trying to answer them by observing and experimenting. So physicists ask really big questions, which is ironic because most of these are not scientific inquiries. How did the universe begin? How will the universe change in the future? How does the sun keep on shining? And what are basic building blocks of matter? Yeah, they're going to have to take a re-look at those. So if something's natural and physical, it must have either chemical formula or structure, charge, mass, momentum or spin, or kcals, kilojoules, or millielectron volts, folks. If it's material, natural, and physical, it must satisfy either one of these, at least. So show us either of these for a vacuum, right? Because this was a subject that was brought up this week. Show us one of those when a vacuum is defined as, even from Wiki, vacuum is a space devoid of matter. So let's look at the definition of physics again. It's a study of matter, energy, and the interaction between them. So how in the world can physicists study matter and energy without matter and energy? Or vacuum. It's devoid of matter. Again, science, the intellectual and practical activity encompassing the study of the structure and behavior of the physical and natural world through observation and experiment. It says physical and natural world to carefully delineate the physical and natural, that's light, helium, nitrogen, oxygen, lightning, tornadoes, electrons, protons, neutrons, etc. Opposed to a theory explained how nature works. So, are these guys talking about the toaster oven laws or the lawnmower theories? I don't think so. Now, on to scientific theories and scientific laws. Before we start into the scientific theories, I hope everyone's aware that there's a difference between scientific theories and the colloquial theory. The colloquial theory is abject speculation. Well, I have a theory on this and this and this. No, you have a speculation on it. It's probably best to use that word because as soon as you say theory, people all of a sudden, relate scientific theory when most people don't know what that is either. But you know what I'm saying. So scientific theories, everything in science is defined precisely. They have a precise meaning. Scientific theories explain the how and the why, the mechanism and the process, and identify the cause, right? Uh-oh, boy, that sounds like a hypothesis, doesn't it? The how and the why and identify the cause, that's like germ theory, right? Yeah, because scientific theories are the result of validated, confirmed scientific hypotheses that have been rigorously tested. That's why they sound like them. As opposed to scientific laws, they only describe. There's a difference between explanations and descriptions. And the difference is explanations answer how, why questions. Descriptions answer what is question. So, for laws, the how and why and the cause is not applicable. They are based solely on observations, often expressed mathematically, because mathematics are descriptions. For example, the second law of thermodynamics. That's why they're called the laws of thermodynamics and not the theories of thermodynamics. There's a reason for that. And a scientific law never becomes a scientific theory or vice versa because they each deal with different questions and both are in two different domains. Again, from Kennesaw State, a law describes what nature does, and a theory explains how nature works. From this view, laws and theories do different things and have different roles to play in science. And remember from our last discussion about scientific laws or physical laws, right? They're not actually scientific. It's a misnomer because no scientific law ever enters the scientific method. It can't enter it. You can't ask a cause and effect question on a scientific law. And I'd use the laws of entropy. We only know that they exist. We don't know the cause of why heat flows from hot to cold or energy from concentrated to dispersed always. We don't know the cause of that. It just does. Okay, that's the science review. Now back to gravity. This is starting to come up again. I don't know for what reason, but let's go over it again. Gravity. Any moron knows that if you drop an anvil from elevation, that it's going to fall to the ground. Conjuring a word that describes the action, gravity, or ducal slope regards, or whatever, I can just make up a term, doesn't validate that it's the cause. It's just the description. However, this is very important. When somebody states gravity in our common vernacular, they are immediately invoking a cause, whether they like it or not. It's either mass attracting mass, that's Cavendish or Newtonian gravity, or space-time, and that's Einsteinian. So Cavendish or Newtonian gravity is a force, whereas Einsteinian gravity is not a force. There's a big difference here, folks. From Caltech, Einstein came up with the theory of general relativity in 1915, the prototype of all modern gravitational theories. Its crucial ingredient, involving a colossal intellectual jump, is the concept of gravitation not as a force. Let's all sing this together. Not as a force, but as a manifestation of the curvature of space-time. These guys are not even in the same geometry. Newtonian or Cavendish gravity is in Euclidean 3 space, whereas Einsteinian gravity is in pseudo-Riemannian 4 space. They are clearly mutually exclusive. So one or the other, you can't be both. So as I said, well, Newton proposed, well, he proposed an equation. Well, this is just a description, right? That's all it is. It doesn't give any explanations. However, okay, let's take a look at these. Newton proposed this equation. However, Cavendish proposed this 100 years later. Now, can you take a look at these? Are these different? I'm thinking so. Newton himself wasn't exactly married to the idea. In a letter to Dr. Richard Bentley on February 25th, 1692, Isaac Newton says, "'Tis inconceivable that inanimate, brute matter should, without mediation of something else, which is not material, operate upon and affect other matter without mutual contact. That gravity should be innate, inherent, and essential to matter, so that one body can act upon another at a distance through a vacuum without mediation of anything else, by and through which their action or force may be conveyed from one to another, is to me so great an absurdity that I believe no man who has in philosophical matters a competent faculty of thinking can ever fall into. In other words, Sir Isaac Newton believes that if you believe in gravity, that you should be institutionalized. Okay, that's pretty clear here. So let's end this Newtonian Cavendish gravity buffoonery quick. So the scientific community, whoever or wherever they are, we have some questions for them, by the way, doesn't follow Newtonian gravity. From George Musser, Scientific American, Einstein created his general theory of relativity, which provides our modern understanding of gravity, with the express purpose of expunging non-locality from physics. Isaac Newton's gravity acted at a distance as if by magic, and general relativity snapped the wand in two by showing that the curvature of space-time and not an invisible force gives rise to gravitational attraction. What are they talking about here? Not an invisible force. What's the juxtaposition? Well, the juxtaposition is between Newtonian gravity and Einsteinian gravity. Is this clear? So, bye-bye Newton and Cavendish. So, now to Einstein. So relativity, that is special relativity and general relativity for gravity in this specific case, but I figured I'd take them both to the woodshed while I was here. Now remember, special relativity and general relativity are not actual scientific theories. They don't follow the scientific method. So, relativity, special relativity and general relativity via different mechanisms, speed versus gravity, can dilate, bend, or warp time. Here's the primary school falsification. I don't even need to get into quantum mechanics falsification. I can stop right here. It's overkill after this. So, time is a conceptual relationship between two motions. Specifically, it's based on alleged single rotation of the Earth on its axis in respect to the sun, a day. It's a concept. It's non-physical. Time is without chemical formula, structure, dimensionality, orthogonality, direction, or location. You can't put some time in a jar and paint it red. I mean, come on now, let's reason together. Can you dilate, bend, or warp non-physical concepts? If you can do this, you need to change your vocation to carnival. Is it your contention that if you have poison ivy on the brain, you can scratch it by thinking of sandpaper? I mean, freedom is a concept too. Can you bend that? Moreover, that which you are using to measure isn't the thing that you're measuring. For example, a football field is 100 yards long, but a football field isn't yardsticks. If I bend a yardstick, does the football field bend also? So if something, say, affects its cesium atomic clocks, or any modern clock for that matter, does that ipso facto mean the Earth's alleged rotation in relation to the sun is affected? These two mytho-mathematical fairy tales, special relativity and general relativity, were falsified 30 seconds after their respective publications by third graders at recess. Each in total, at best, at the very best, are massive reification fallacies on nuclear steroids. So, let's put the final death knell into this, and I'm sure everyone's going to be able to see this relatively quickly. So, Martin Rees, astronomer royale with cheese, esteemed British cosmologist and astrophysicist. What causes gravity and mass? These questions still baffle all of us. What? And we have everyone appealing to Newtonian or Einsteinian or combinations thereof? Why? According to Professor Rees, does mass attracting mass cause gravity? No, he's still baffled. According to Professor Rees, does space-time cause gravity? Nope. So why are we hearing this term gravity? Everyone appeals to it. Why? Can somebody tell me why? Therefore, gravity is merely a conjured term that describes an effect. It's not a cause. Thank you very much. Have a nice day.
Absolutely awesome. Is that genuinely the end of the presentation?
That is genuinely the end. What more do I need?
That's a recap. I mean, you've done this with cathexis, but
Yep.
slightly altered, not exactly the same, but pretty much the same.
Well, we got into more detail. I not only provided the primary school falsification, I went into the quantum mechanics falsification, but I don't need to do that here. I don't need to do that. We'll talk about quantum mechanics coming up. We'll get to him in a few weeks.
Sure. I mean, I just appreciate the fact that you're going over the same stuff because it needs reiteration for it to sink into a lot of people's mind. And it's nice to see people like Dan Pratt out there talking about the scientific method right here, right now, and others joining the panel on the debates and actually, employing it, using it to destroy ballers. I mean, I will keep this relatively short and sweet, John, but one thing I will say is the irony level is just upped by 1,000% recently because we are called science deniers. And we're not. We're pseudoscience deniers, as you put so eloquently.
Exactly. It's flipping it on its head because what have we been told for the past 3 years? If you believe in the flat earth, you must deny all of science and all of physics. And you're religious, you flat earthers. But what is it actually? It's a complete flip. It's a reversal. They're the religious zealots and the religion believers, and they must deny science, the scientific method. How ironic.
Yeah, exactly. The irony that the undoing of the globe, which has apparently got the entire body of science behind it, is the scientific method. Just pure irony.
It certainly is, sir. And a lot of people are seeing it now. And I think and like you said, repetition is so important. It may seem redundant, but I think it's really important for people to understand this stuff because most people, your average Joe Coffey and Betty Breadmaker, they haven't been in school for a long time, right? Or if they did any schooling, it didn't go past high school. Nothing wrong with that. And they forget what science actually is. And it's not hard. I mean, it doesn't take a rocket scientist, just launch pad security, to figure out what the scientific method is. It's quite simple. And it's simple for a reason, right? Anyone can do it. Anyone can do it.
And another thing that's just crossed my mind since you said was a point that Numinum brought up, which is that it has limitations, but those limitations are there for a good reason.
The limitations of the scientific method is cause and effect. If it's not a cause and effect question, it's not a scientific question, right?
Well,
there's
maybe
other ways.
I was just going to say, maybe I can parrot a question that was asked to you by Philip, who's studying to be a PhD, as I understand it. He said, well, what happens if you've got more than one variable? What do you do then?
It's not science. If you can't isolate your independent variable, you don't know that variable is causing the effect. You follow? You can never pin it down.
Simple stuff. That's why I like it. I'm not the smartest guy in the world, but I can get it easily and employ it and use it. And people who I previously considered my intellectual superior, ultimately speaking, are undone by this scientific method when applied to any of their ball earth proofs. All of them are based on models and presuppositions. It never changes. And another phrase you've used, which is rinse and repeat. We're going through this process, and you will see it, although I'm starting to call people on it, the process of asserting something, having it be debunked or picked apart very slowly in the debate process, and then they reassert it right after, just exactly the same, like we've not gone through any of it. It's an amazing process that they go through.
It happened today. Yesterday, somebody brought up, differing weights at the equator and the North Pole, and we demolished it because it was easy to, because there's nothing there. There's nothing scientific there. And then I turned it on this morning. I woke up late. I turned it on this morning, and guess what I hear? It's the same person bringing up the same argument. I'm like, wait a second.
Yeah, Lewis Hackett brought up the exact same argument after being taken through the steps of the scientific method and showing him why it didn't have any of the requirements covered. He had the observation covered. That was it. The observing a phenomenon. That was it. That's all he had covered. From there on in, his hypothesis fell apart, and it was loosely explained to him on the spot, but none of it sunk in. Not that, like I say, the reason I'm pleased this is happening is because it's not necessarily going to sink into anybody's mind unless they hear it repeated and get familiar with the process being employed, and hopefully that's being seen on the debates. People actually seeing how you undo most of the ball earth arguments, most if not all, are based on the presupposition that you're on a ball.
Yes, and like I said before, every single scientific proof, in quotes, from the spinning dollars is an affirming the consequent form of logical fallacy. Now, I didn't go over that in here. I'm going to save that maybe for a different presentation. But every single one is just like that. And remember, observing phenomena is only the first step of the scientific method. I mean, everyone can observe phenomena. That's fine. We're good to go. Yeah, you can pass that step. The problem comes in when you get to step 3. Construct the hypothesis. See, that's where it stops, because if it's something that you can't get a hold of, that you can't vary and manipulate, that you can't confirm that it's the cause of your predicted effect, then it's over right there. It stops. You stop at the scientific. You can't get to an experiment. It's over.
Yeah, it's all about the if and then relationship, the cause and effect, the independent and the dependent variable. And the independent variable in many instances is things like Earth's sphericity or Earth's turning. And you go, well, you can't get hold of those things, as you put it. You can't manipulate them. They can't be an independent variable. It's as simple as that.
Yeah, it's as simple as that, because you can't isolate it, then validate it that it's your cause. See, all they're doing is, like I said, affirming the consequent form of logical fallacy, because you can't test or confirm anything. All they're doing is giving an observation of a phenomenon and a just so story explanation. No test, no nothing. It stops right there. Observe a phenomenon, give you a story, right? And then ask you for your story. Well, I don't have a story, and I don't need a replacement story to pummel your fairy tale story. So I don't know. That's all it is. It's nonsense. I'm sorry. It's what it is. It's nonsense.
Yeah. I mean, again, you summed up something that Numi said on the show earlier today, which is to say the most scientific answer, if you don't know something, is to say that you don't know, rather than just make up a just so story and tie that in with an observation. Just before we do end, though, John, can you round out maybe by saying the difference between an observation and observation of a phenomena?
Yeah, an observation. Now, anyone can make an observation. There is no scientific observation, by the way. I mean, the scientists don't have different eyes. They're not calibrated, right? We all have eyes. So scientific observation and observations are observations. Okay? Now, the difference between observation and observing a phenomena is, like I said, there's a tree out in my backyard. If I look out my back window, there's a tree out there. That's a concrete noun. I can't ask any more questions about that, because I wasn't here when it was planted. I just see a tree out there, right? I can't ask any questions. Now, if there's leaves falling off it, that's a phenomenon. I can ask a cause and effect question about that, right? Because that's a phenomenon. It's not a concrete noun. You can't look at a tree and then come up with a hypothesis, because it's inane. There's nothing there. There's no meat on the bone there. Even though we know how trees are created, in a vacuum, for the lack of a better term. I just can't look at something and it's a concrete noun, there's no phenomena, and come up with a hypothesis. I can't do it. It's not conjure a phenomenon from a concrete noun, it's observe a phenomenon. And more importantly, from Niels Bohr, said that a phenomenon isn't a phenomenon unless it's an observed phenomenon. And that gets into quantum mechanics, because if you don't observe it, then you're out of luck. And like I said, we'll get to that here in a week or two. And hopefully people understand it.
Excellent. Was there anything else you wanted to add before we round out proper?
No, that's good. I think this was a good presentation. It was short, concise, to the point. Hopefully people will come back to it and just review it. Maybe practice a couple hypotheses, what they think are hypotheses, and just try to apply it themselves, right?
Yeah, we had exactly that earlier today with Arwin. So he tried to formulate it, he failed miserably, but ultimately you've got to try and you've got to fail in order to succeed eventually. So hopefully people will do exactly that and pick up on some of the stuff that you're putting out there, John. And ignore the ridicule, as you started off the show by saying that you've received a lot. All it means is you're close to the target if you're getting a lot of flack. So I'm almost pleased to hear it, not quite. But with that, I will say a massive thank you to you, John. Pleasure to have you.
Thank you, sir.
And also, I will say a massive, huge, enormous thank you to all of the live audience for tuning in and hopefully for sharing this show. If you've not done so already, be sure to like, comment, share, and subscribe. I've been Nathan Oakley, and I will see you all in the next video.
Oh, what a day! What a lovely day!
Shalom, people. Shalom, people. Shalom, people.